An engineering project is expected to produce a reliable product within a limited time using limited resources. Projects, however, runs the risk of not producing the desired output of the product. It's because of overspending its resource budget or overrunning its allotted time. So, let me share some knowledge about risk management in order to lessen the risk you may take. So first of all, what is risk? Risk is the possibility of suffering danger, harm, or loss. There are techniques to identify project risk. Knowledge for these techniques increases the chances of success of a project. So, there are 10 typical software engineering risks which might help you as a future engineer. First, personal shortfalls, or lacking of forces to do something. It could also mean that you don't have the right people assigned for a position or for a project. For example, you assign a programmer without knowing that that guy don't know how to program or code. That's a defect and surely takes risk. So, these are the countermeasures for this kind of risk. Staffing with top talent, job matching, team building, key personal agreements, cross-training, and pre-scheduling key people. Second, unrealistic schedules and budget. This is where your schedules and budgets are unsure, like just setting it away here. So, the risk management technique for this one are detailed multi-source cost and schedule estimation, design to cost, incremental development, software use, and requirement scrubbing. Third will be the developing the wrong software functions. Basically, the output of the software is not the one expected by your client. So the risk management technique for these are organization analysis, mission analysis, ops concept formulation, user surveys, prototyping, and early users manuals. Fourth will be the developing the wrong user interface. More likely when you are developing an unfriendly interface just like this one, where buttons are unnecessary and it's quite messy. So the risk management techniques for this one are prototyping scenarios, task analysis, and user characterization. Fifth one will be gold plating. It is basically making a change beyond the project scope under the assumption that it would make the product better, but it might not. So the risk management techniques are requirement scrubbing, prototyping, cost-benefit analysis, and design to cost. The sixth continuing stream of requirements. This is just like gold plating, but the thing that you wanted to change are essential might cause risk for the project. So the risk management techniques are high change threshold, information hiding, and incremental development. Seventh will be shortfalls in externally furnished components. Customer furnished components that may be a poor match to a new application, just like a commercial component that took great in vendor brochure and demo, but turned out to be immature in reality. This kind of risk will be avoided by benchmarking, inspection, reference checking, and compatibility analysis. Eighth will be the shortfalls in external tasks. Optimistic statements by customers that they will provide instant turnaround on reviewing and approving the developer's specification and plans. To handle this kind of risk, you may reference checking, pre-award audits, award pre-audits, competitive design or prototyping, and team building. Ninth will be the real-time performance shortfalls. This is about specs which did not meet the expectation of the users. So, have these risk management techniques to avoid this: simulation, benchmarking, modeling, prototyping, instrumentation, and tuning. Lastly, we have this training computer science capabilities. And just follow these risk management techniques to handle this: technical analysis, cost-benefit analysis, prototyping, reference checking. Now you've learned about the software engineering risks which may help you as a future software engineer. But wait, we're not done yet. There's still more. Now let's tackle about the Capability Maturity Model, or also known as CMM. So CMM is developed by the Software Engineering Institute. It aims to help organizations to improve the quality of the software they develop. So there are two kinds of maturity: the immature and mature organization. Immature organization produces products which often delivered late and their quality is questionable, while mature organization is the exact opposite. They focus on continuous improvement both in performance and quality of the product. There are 5 levels of CMM. First is the initial stage. You can say that an organization in this level, their activities are ad hoc, which means things are done just when necessary. Also, it's quite chaotic, where the staff works on its own without teamwork. So the second level is repeatable. Does not depend exclusively on individuals. Staff works as one organization. The required input and output of the process are clearly identified. And also, it has a clear schedule and budget, which makes the process repeatable for to have their goal. Level 3 would be defined. In this level, the organization's repeatable process are documented and standardized and integrated. Level 4, however, is managed. The organization sets quantitative goals for both the process and product. Project and process data are collected and analyzed, then used to perform corrective actions and improvement while the project is running. Level 5 is optimizing. The organization is focused on continuous improvement and is built to pivot the respond to opportunity and change the organization's stability, providing a platform for agility and innovation. That's all. Thank you.